That's why I purposely left a bigger gap from 0 minus to 0.
Black pen, red pen, yay!
Today, I'm going to discuss the debate of this integral from negative 1 to 1 of 1 over x dx with you guys. And the reason that I said this is a debate because it seems like there are two ways to interpret this integral, and it seems like there are two answers as well. So I will demonstrate both, and after the video, you guys can comment down below and let us know what you guys think. Okay, here is the first way to look at this right here. Notice we do have this from negative 1 to 1, so it's symmetrical, huh? And then this is 1 over x, which is an odd function. And by one of the properties of integral, we know that we have this. When you go from negative a to a of an odd function, and let's put on dx, otherwise your calculus teacher will be mad. This right here, we know this is equal to 0. Therefore, it seems like this right here, by this, it's equal to 0 right away. However, this part is only true when you have a continuous odd function. We know 1 over x, it's not continuous because we do have a vertical asymptote when x is equal to 0. So I don't think we can use that directly. But you can also bring out a picture to argue this. So let's take a look of the graph of 1 over x. So let me put this down right here. 1 over x looks like this and like that. I know my picture is not the best, but I try. Anyway, this is the graph of 1 over x. And we are going from negative 1 to 1. So let's say this right here is negative 1, and this right here is positive 1. And as we all know, when we're calculating the integral, we're trying to find the area under the curve. That's one way to interpret it, right? So if you go from negative 1 to 1, you're talking about this and that. And here, it seems like this region and that region have the same size. But this is down below. Therefore, this has negative area, right? And this should be cancelled with that, and you do get a 0. It seems like it. These are the two usual ways that people will think why this should be 0. And now, let's take a look of the definition of improper integral, and that's the second way right here. First of all, we do have to notice 1 over x has the vertical asymptote when x is at 0. So that's why it's an improper integral. Therefore, we must break this into two pieces. This right here, we are going to first write from negative 1 to 0, but we are going towards 0 from the left-hand side. So that's technically 0 minus. So I'll just put this down right here. And then, of course, we write down the function 1 over x, and then put on the dx. And then the second part is we add the integral, and you go from 0, but this time it's going from 0 from the right-hand side. So put down 0 plus to 1. And then, of course, write down 1 over x dx, like that. Okay, so this is pretty much how you can just break down into two pieces, and now you have to just work them out individually. But I do want to mention this before we continue. This right here, the proper way to write down an improper integral is you have to write down the limit. So I will write this down for you guys for at least one time right here. This right here is you have to take the limit, and let's use b for this, because usually when you have an integral, it's from a to b, and since this is up here, so let's just say b. You take the limit as b going to 0 minus, and then you write this down again, the integral from negative 1 to, you don't write this down, you write down b, and then 1 over x dx. So in order for you to make sense of this, you have to talk about the limit. And likewise, this is similar, and you just write down the limit as a approach to 0 plus, and so on. But I'm going to leave that out because I'm going to just write down the shorthand way. What I mean by that is, first, let's integrate 1 over x, and the antiderivative for that is ln, absolute value of x. Remember, we must put down the absolute value because originally, 1 over x, we can plug in negative numbers for x right here. And in order for us to be able to plug in negative values for x right here instead of the ln, we must have the absolute value. This is why. And then you continue by plugging the -1 and 0 minus, you can just write it down like this. This is just one, the shorthand way to write this down. And if you want to write down the proper way, it's this. And secondly, we also put this down, we add, it's the same antiderivative, ln absolute value of x. But this time, we go from 0 plus to 1. Now, these are two different questions, right? Technically, two different parts. Let's talk about the first one. Right here, we do have to plug in 0 minus into here, so it becomes ln absolute value 0 minus, and then that's the first part. You subtract the second part, you plug in this right here, so ln of absolute value of -1, like this. So now let's just focus on this part right here. What's ln of 0 minus? Well, 0 minus is just like negative 0.0001, and because of the absolute value, it becomes positive, right? So this right here, you can interpret it as ln of 0 plus, and to get this, you have to look at the ln graph, which is like this. This is ln x graph. When you approach 0 from the right hand side on the ln graph, you get negative infinity because the graph goes straight down. So the first part is negative infinity. And of course, you could have also looked at the graph of ln of absolute value of x. If that's the case, you pretty much have the other piece that goes like this. Right? So up to you, depending on if you want to use the absolute value right here or not. That's the first part. And now for the second part, we know that this is ln of absolute value of -1. In other words, ln of +1. And we know this right here is just 0. So we have negative infinity minus this is the 0. And this right here, in fact, we can draw a conclusion already. Negative infinity minus 0. Of course, this right here diverges. Done. And seriously, this is the done deal because this came from this part of the improper integral, and we are done. In fact, we don't even have to talk about what the right-hand side, what this part is going to be. And I know a lot of you guys will be asking, if we work out the computation, in fact, we'll get something similar. So I will do that real quick. ln1 is of course 0, and then this right here is negative infinity. And check this out. It seems that we're just adding 0, and then minus becomes positive infinity. So the trouble is, if you have this and that, it seems like negative infinity plus infinity should be 0, isn't it? But this right here, as we all know, infinity minus infinity is an indeterminate form. However, they have no connection with each other anymore because this right here was supposed to be just from this part. And likewise, this right here is from this part, right? So it's two separate things now. And you cannot really do any algebraic work to simplify it or whatsoever to talk about anything, whatever. So seriously, when you have this kind of situation and when you break down into two pieces, if one of the piece is a divergent, done deal. You can just say the whole thing diverges. So the response for this is just a divergent. And a lot of you guys will be wondering, how come this doesn't make sense? Well, I'm going to talk about the graph again, and let me just make the graph again. Okay, let's talk about this piece first. We want to go from -1 to 0 minus. And let me just say this right here is -1. And I want to look for the area on the curve. So we make a mark right here. And then we have to go to 0 minus. So I will just mark it here, say this is 0 minus. And you all know the idea. This 0 minus means that I want to have a number that's toward 0 from the left-hand side, right? And this is trying to calculate the area of this region. And as this going towards 0 from the left-hand side, we know this area is going to be negative infinity. And the reason it's negative is because it's down below of the x-axis. And as you can see, this right here tells you the area is negative infinity, right? So it agrees. And now let's look at the second part. It goes from 0 plus to 1, but I will write down the 1 first. And we have to keep in mind, I have to make sure we have the same distance. So I will say this right here is my 1. And we have to go back to 0 plus. I will just mark maybe right here this time. I'm doing this on purpose actually. Okay, this right here is my 0 plus. And we are talking about this area here. And as this number going toward 0 from the right hand side, this is also going to give you infinity, but it's going to be a positive infinity. Notice that I put down this 1, the same distance, right? Because of course they are both distance 1 away from 0. But the 0 minus and the 0 plus, they do not have to be the same distance. Once again, 0 minus and 0 plus, they do not have to have the same distance away from 0. That's why I purposely left a bigger gap from 0 minus to 0, and also a smaller gap from 0 to 0 plus. As you can see, the trouble is that when this area gets to be negative infinity, in fact, it has no connection with this area that's going toward positive infinity. You don't know which infinity will win. And seriously, even though when we have this indeterminate form right here, but remember, whenever we had the indeterminate form in a limit situation, we have to somehow combine it, somehow do some algebra to simplify it. But in this case, we cannot do anything. We cannot do anything from here to here. And the conclusion is that this right here, it's divergent. And hopefully this picture right here makes some sense now. And leave a comment down below and let me know which one do you think that should be the case. Are you still on team 0 or you move to team divergent? So leave a comment down below and let me know. And if you like this video, be sure to subscribe before you go. Thank you so much. That's it.